Okay. So phospholipids, they are major components of the plasma membrane. We do know that. So what is the structure of the phospholipid? So they compose of two fatty acid chain, highlights, and attached to one glycerol. And the third carbon of the glycerol backbone is occupied by the phosphate groups, okay, occupied by the phosphate groups. So if you look at the structure here, you can see that this is the glycerol. Glycerol is a 3-carbon alcohol, OH, OH, OH. So how the reaction take place? Reaction take place between the alcohol and the fatty acid. So the bonds that form, okay, the bonds, okay, CO, C double bond O here is the what we call as the ester bonds, okay, it's the ester bond. Can you see that? And the third group, the alcohol here attached with the phosphate group, okay, attached with the phosphate group. So this phosphate group actually can attach with additional items here or molecule here to increase the what we call the hydrophilicity here. Okay. So the phosphate may be modified by additional charge or polar chemical group to increase the solubility. So two chemical group that can modify the phosphates at the phospholipid molecule that are here can be cholines or serines. Okay, cholines, then you can get the phosphatidyl cholines, or a serine will be phosphatidyl serines. Okay, this extra information for you guys. So there are two important parts of the phospholipids, the head and the tail. The head, which is hydrophilic, and the tail, which is hydrophobic. Okay, so for today, we're going to look at how the formations of the phospholipids molecule actually can take place. Okay, so we need to show how we can use a stearic acid and oleic acid or both. Draw a diagram to show how a phospholipid can be formed. Okay, now in the exam, you need to know how to draw the diagrams, okay, and show how the process actually take place. Okay, now since they give me the formula like this, I'm going to use the formula rather drawing the entire thing. I don't want to draw entire things here. Okay, so let me add another page so that I can draw to show you guys. So how we can form this phospholipid molecule? First, we must have glycerol. So we need to know the glycerol. So glycerol is C, H, H, then OH, C, OH, H, C, H2, OH. So this is glycerol. So glycerol will act with two fatty acids. So how we move, I put a fatty acid here. So I use brown color fatty acids. In this case, we're going to use, okay, depend on what you like to choose. You can choose the stearic acid, which is a C17H35COOH, or you can use oleic acid, C17H33COOH. Okay, so I use the stearic acids. Okay, so the first one, C double bond O, OH, and then C17H35. So this is the stearic acid. I can have another one. I can use a different one. Okay, this one may be C17H33 oleic acid. Okay. Now the third one, I changed. So I put the OH here. Easier for me to draw. So I put OH and H. So the third group here, we're going to react with the phosphate. So phosphate, in order easier for me to explain, I use a phosphoric acid. So phosphoric acids will have P, double bond O, OH, OH, OH. So we have three components. This is a phosphate group. And these two, they are fatty acid. So one phospholipid molecule, okay, one phospholipid molecule is going to have the two fatty acids, one glycerol, and one phosphate group. Okay, now this is something like an esterification process. The name of the process is known as esterification because we want to form the ester bond. In order to form the ester bonds, glycerol, alcohol donate H, hydrogen atom. Okay, and then the fatty acid donates OH group. So form one water molecule, second water molecule. The third water molecule will be here. Are you clear? Get the idea? So you need to know. So how will I show it? So I say this one, remove as H2O. So this process actually is a condensation process. Are you clear? Condensation process when you actually remove the water molecule. Okay, so what is the final outcome? What is the final outcome? So C, glycerol, H, C. Okay, sorry, O, no, C, sorry, O, C, O, H, C, H2, O. Okay, then bond with who? Bonds with the first one, our stearic acid, C double bond O, C17H35, C double bond O, C17H33, the oleic acid. And the last part here, you have the phosphorus, P. Oh, it's a green color, sorry. P double bond O, OH, OH. Okay. And don't forget, in this process, we remove 3 water molecule. So the balance equation, 3 water molecule here. Okay. Now, when this phospholipid molecule exposed to the aqueous environment, what will happen here is ionization, because this part is a phosphoric acid, so ionization actually take place. So means that the H, okay, the H actually will dissociate. So when H dissociates, the O here will be charged negative. Can you see that? When the H dissociates, right, acid ma, right? So they donate the protons. When they donate the protons, then you can see that now this part charged negative. So making the entire structure here hydro is a head, which is hydrophilic. Because they are negatively charged, they can actually interact with water molecule, where we're going to learn it next topics, okay? How the water molecule can interact with the charged particle, okay? And then this part contributes to the tail. So we call it hydrophobic tail. Are you clear? So it means that the regions that hydrophilics, because they can interact with water molecule, that's why the hydrophilics. Another region is hydrophobics. So when hydrophobics, they repel, they don't like the water molecule. So it means that when you draw it, the hydrophilic head, so with the tail, hydrophilic head with the tail. So the tail always interact with the tail. Why? Because they are hydrophobic. So hydrophobic always hydrophobic. Hydrophilics actually will face the aqueous. So it means that you have the H2O here, water molecule. For example, tissue fluid. And here, cytoplasm. And this one is the internal hydrophobic core, which act as a barrier for the charged and water-soluble molecules. Okay? So with this, I stop, okay, for phospholipids molecule.